Hi there, this is Molendinarius here from MiFa, Tota Musica, which is part of Latinum. The video we're going to look at is a discussion of metronomes, so that may be a little bit boring for some people, and how it was understood that a metronome should be read. And we're going to look at some of the very earliest sources about the metronome, which is a relatively modern invention. We're starting off with the Encyclopedia Britannica and its entry on this. The silent metronome is impelled by the touch and ceases to beat when this impulse dies. And we need to pay attention to this word beat because it becomes very important later on. It has a scale of numbers marked on the pendulum. Another word we need to pay close attention to. There's no attempt at redefining how a pendulum works in any of the early discussions of the metronome, which is simply an upside down pendulum. And the upper part of the sliding weight is under that number, which is to indicate the quickness of a stated note, as in MM, Mazel's metronome, so on and so forth, 60, 72, 108, or the like. And the next sentence is extremely important. The number 60 implies a second of time for each single oscillation of the pendulum. Now, if you want to know what an oscillation is, consult your dictionary. But it is a movement back and forth. Not just a tick, but a tick-tock. In other words, one beat of the metronome is not tick, but tick-tock. And we will see in subsequent sources that this is spelled out quite explicitly. Numbers lower than this denoting slower and higher numbers, quicker beats. A more complicated metronome is impelled by clockwork, makes a ticking sound at each beat, beat being oscillation, and continues its action till the works run down. A still more intricate machine has also a bell, which is struck at the first of any number of beats willed by the person who regulates it, and so signifies the accent as well as the time. So much for the very first section. We're going to go through a number of sources here, and this is the first, the Encyclopedia Britannica, just to lay out the definition of oscillation. I'm now showing you a picture from Huller's Time and Tune. Huller was an important musical educator in London in the 19th century, and you can look up his biography, John Huller, on Wikipedia if you want to find out more about him. And this is what he has to say, and here we have one more item of the 19th century vocabulary related to metronomes that we need to understand. Although, for the purpose of keeping time in musical performance, the metronome never has been, nor perhaps ever can be used, for the purpose of indicating it, it is most valuable. When at hand, it is, of course, an indisputable evidence of the intention of the composer. Note that. And even when not at hand, it is hardly less useful, since a moderate degree of practice will enable a conductor or performer to remember the pace at which the pendulum vibrates. Another word here, vibrates, which you need to look up in your dictionary. It is the same as beat and oscillation, a movement back and forth. So not a tick, but a tick-tock. When a string vibrates, it goes from one side and back to the other. When the weight is in this or that position, and thus to carry out the design of the composer, if not perfectly, at least with far more certainty than when aided only by such words as andante, allegro, etc., etc. And now we will continue on, because as we go on in this discussion, we will get more and more explicit instructions for the use of this machine. And here we have Huller's instructions for the use of the metronome from his book Time and Tune in the Elementary School. Written at a time when the metronome was still relatively unknown, and so very explicit directions were required. And this is what he has to say. Masel's metronome consists of a pendulum having an index which is furnished with a weight movable along its whole length. On the position of this weight depends the pace at which the pendulum will oscillate to and fro, i.e., the number of oscillations it will make in a given time. Now, if this is not extremely clear, I don't know what is. An oscillation is a movement back and forth, and the position on the weight gives you the number of times there is a movement back and forth. An oscillation, a tick-tock. The figures on the index indicate this number per minute, number of oscillations per minute, number of movements back and forth per minute. Supposing the weight to be placed immediately under any one of them. Thus, if the top of the weight be placed against the line marked 160, the pendulum will make 160 vibrations per minute. This word vibrations coming up again, which is a synonym for oscillation. If it be placed against the line 50, it will make 50 vibrations per minute. The former being the largest, the latter the smallest number possible for this particular pendulum. And notice there's no attempt to redefine the science and understanding of pendulums and how they work. And the Masel's metronome was simply understood to be a pendulum working exactly the same way as a weight hanging from a string. A composer or editor who desires to indicate the exact time at which a given movement is to be performed has only to mark against the form of note, which represents each beat, the figure under which the weight is to be placed on the index, and the pendulum will oscillate at the pace at which each beat is to be made. Oscillation meaning movement back and forth for each beat. Thus, the 100 means that each crotchet is to be performed, and each beat equal to a crotchet made in the time of one oscillation of the pendulum, the movement back and forth. Tick, tock. It cannot be more clear. When the weight is placed against the line marked 100. In other words, there is absolutely no argument here or room for wiggle about how we are to read a metronome. And this is from an authoritative source. John Huller was a very important musical educator in London at this time period. And the book I am referring to is Time and Tune in the Elementary School, a new method of teaching vocal music by John Huller. And this you can find on Google Books or on archive.org if you want to consult the PDF of this book yourself. And if you are curious about what Mr. Huller looked like, here he is. Before I continue on with more discussion of the metronome itself, I want to have a look at Tansur's The Grounds of Music, 1734, a very early text, where he discusses tempo. And what he has to say, I think, is very interesting. So we find this here. The semi-breve, note number 1, whose length and proportion of time is so long as you may leisurely tell 1, 2, 3, 4 by the slow motions of the pendulum of a large chamber clock, or any other pendulum of the like proportion, it being the longest note of any now in use, though formerly it was the shortest. So if you are uncertain about what this sounds like, go onto YouTube and search for grandfather clock and listen to the beat of the pendulum of such a clock, and this will give you an indication of time and tempo as it was understood in the 18th century. Now let us move on to the metronome and tempo and oscillations and vibrations and beats and so on and so forth. Our next printed source about the metronome is by Henry Wilde in a book called Harmony and the Science of Music, complete in 1 volume, the principle of the London Academy of Music, which then became the London Academy of Music and the Dramatic Arts, which still exists today, but following the Second World War, no longer specifically teaches music, it only teaches dramatic arts. So this is Henry Wilde. Let us see what he has to say about this newfangled thing, the metronome. So this is what Wilde has to say, and in his discussion he's using more scientific language, where he uses the word period for what we have called oscillation before now. When a physicist talks about the period of a pendulum, he means tick-tock. The period of a pendulum is the movement of the pendulum back and forth, and that you can check with your encyclopedia or your Wikipedia or your Britannica or whatever reference you wish to look up. There's no dispute about this whatsoever. So on the actual duration of time, the actual duration of time due to each comparative period or to measures formed of them can be known on finding the value in actual time of any one. Thus, if the crotchet is the duration of time occupied by the movement of a pendulum 1 foot in length, from its place of rest to its place of rest. In other words, Wilde is not assuming that you know what an oscillation is. He's not assuming you know what a beat is. He is spelling it out for you in black and white. From its place of rest to its place of rest. Tick, tock. So when it starts, that's the place of rest. It moves like that and it goes back to its place of rest. Or you could say it's in the center. Here's the place of rest. And it goes here and it goes there and it goes back to the place of rest. It amounts to the same amount of time having elapsed. But in terms of counting, of course, it's easier to go tick, tock. The place of rest being where the pendulum stops, notionally. So, a pendulum 1 foot in length from its place of rest to its place of rest. The duration of a minim is equal to the time of 2 such movements, and the quaver to half the duration of 1 such movement. The value of the crotchet, etc., is not always thus given. Quicker than allegro, etc. The accurate duration of time intended to be given to the breve, semi-breve, etc., can be easily known if a machine called a metronome is used, and if the value of... And so we continue on with the note. When no metronome is used, a pendulum made of string with a weight attached answers accurately enough to denote the value of the breve, etc. For a breve, etc. can be said to be of the value of the vibration of a pendulum of a specific length, remembering that the vibration of a pendulum is its movement back and forth, i.e. from its place of rest to its place of rest. For example, the value of the breve is the time occupied in the vibration of a pendulum of 12, 13, 14 or any other number of inches in length. In using a pendulum of this kind, it is advisable to understand the following rules respecting it. Pendulums of equal lengths vibrate in equal times, even if their weights are unlike. In pendulums of unequal lengths, the times in which they vibrate are as the square roots of their lengths, and thus the lengths of the pendulums are as the squares of the times in which they vibrate. Therefore, a pendulum which is to vibrate twice as slow as another must be 4 times as long, and vice versa, only a quarter as long, in order to strike twice as fast. And of course this gives rise to great inconvenience, because very great long pendulums are needed if you are going to have music that is regulated at a slow tempo, which is the great advantage of the metronome with its inverted pendulum. We're now moving on to another 19th century source, this by Matthias Lui, who was an organist in Switzerland, who wrote the Traité de l'expression musicale, and we are looking at this in translation, where he deals with tempo. So let us look at Lui. He writes, "It is essential to familiarize the pupil with the metronomic figures corresponding to each of the principal rates of movement, and to ascertain at the commencement of each piece that the executant is familiar with this relationship. In order to facilitate this task, we have compiled a table showing the relationship between the terms generally used to express the rate of movement and the number of metronomic oscillations, that word again, corresponding to each. Before presenting this table to the reader, we must explain the principle upon which our estimate has been based. It appears to us," continues Lui, "logical to apply the metronomic indication of speed only to the duration of the beat or the measure, for they are the only units which the ear can recognize. If the duration of the beat be indicated metronomically in common or 4/4 time, the crotchet representing the beat, Mazel's metronome MM, equals 60, signifies 60 beats in a minute, 80 beats in a minute. If the duration of the measure be indicated metronomically, the first example would be expressed MM, breve 15, the second 20, that is to say 15 or 20 measures in a minute." Lui continues, "It is not reasonable to give a metronomic indication of the value of a note which does not express either the duration of a beat or of a measure. For instance, in a piece in 6/8 time, do not mark the duration of a crotchet which in this time is only equal to 2/3 of a beat. In a piece of 3/4 time, 3/4 time, do not indicate the value of a minimum which in this time only represents 2/3 of a measure in the minimum. In an edition otherwise excellent of L'invitation à la valse, an allegro is marked 88. Why is this minim used? The piece is in 3/4 time. If each oscillation of the metronome marks a beat, notice he's very clear here, oscillation of the metronome marks a beat. This is why we're looking at this source, because he is very, very clear about what it is that a beat of the metronome is. It is an oscillation. It is a tick-tock, not a tick by itself. It should be expressed by the crotchet. If, on the contrary, it marks a measure, it should be indicated by a dotted minimum. All other formulae are objectionable and the cause of confusion. But what's important for us here in this source is his very clear, in black and white, explanation of what is meant by the beat of a metronome, which is the oscillation. Because there are some modern writers who are not well versed in physics and don't understand how the metronome was intended to be used, who think that the tick is the beat and not the tick-tock is the beat. Let us continue. So in this continuation, Lui reiterates his definition of a beat. Liszt has committed an anomaly of this kind in Regata Veneziana for giving 6/8 time the formula of 192. This crotchet is equivalent to neither a beat nor a measure, nor even a third of a beat, but to 2/3. It is probable, however, that this is a typographical error, for the indication 192 would give a too rapid rate of movement. In consequence of triplets, there are as many as 9 notes to one beat, which at 192 is impossible. Liszt probably intended to write quaver 192, which we should translate as 64, and which in this time correctly expresses the duration of the beat. In the compilation of the following table, we have therefore considered each oscillation, to repeat, oscillation, movement back and forth, of the metronome as being equivalent to one beat. Whatever the note by which the beat be represented, and that equally for compound as for simple time. So when we look in 19th century sources about metronomes and we read the word beat, we need to be aware that beat means oscillation. It's tick-tock, not just tick. I keep reiterating this because some people seem to think that this is not the case and play their music much too quickly. For instance, 80 here signifies that the pendulum makes 80 oscillations per minute, each of which requires a crotchet. It is therefore necessary to play in 1 minute 80 crotchets, or 40 minims, or 20 semi-breves, or 160 quavers, etc. Compound time, as well as simple time, with ternary subdivision, having 3 notes in the place of 2, it is necessary to bear in mind this increase in the number of notes, which will evidently give to a movement a more rapid pace. And here is Lucy's table. Largo, adagio, larghetto, 40 to 60 oscillations per minute, an oscillation being tick-tock. Andante, andantino, 74, and so on and so forth. So this is the table of principal terms used to express the rate of movement, with the number of metronomic indications corresponding with each. And he notes at the bottom, it should be understood that we do not pretend to attach to each term a fixed number of oscillations. So there is some variation here. Different composers have different things in mind. And finally, we have Lucy's advice on how to proceed. We advised composers to abandon completely these Italian terms and to replace them with the metronomic indication, carefully and exactly calculated. They will attain this end if, before deciding on the figures, they examine the contexture of the new composition and then play it at 3 or 4 different rates, sometimes in the evening, sometimes in the morning. They should consult the metronome each time, not only before commencing, but in the midst of the piece. If they mark each time the figure corresponding to their pace, the average of these figures will give the correct rate of movement nearly exactly. We advise amateurs and pupils to repeat frequently the following exercises. 1. Beat at the rate of speed indicated at the head of a piece without consulting the metronome. Then verify and correct the beating with the instrument. 2. Play the commencement of any piece with the assistance of the metronome. After a pause, play it again, at first without the instrument, in order to correct and rectify the speed. 3. Mark the figures which different authors give for Italian words. The word andante, for instance, in various works, classic as well as modern, and compare the variations. When the movement is too fast, there is a liability to confusion. It is therefore better, in very fast movements, to reduce by half the number of oscillations. For instance, in a piece in 4/4 time with 160 beats, only make 80 per minute and consider each oscillation as being equivalent to a minimum instead of a crotchet. If the movement is too slow, there is the